This video is about proportions that exist within triangles, and the two specifically that we're going to look at, I like to refer to them as side splitter and triangle angle bisector theorems. Okay, so what does side splitter say? Side splitter says if you have a triangle and a small triangle inside of it, in other words, two of the sides are parallel to each other in these two triangles, okay, then what it does to the other two sides of the triangle is it splits them up proportionally. So I know that this side compared to its partner on that side, how it gets split is equal to the same ratio of sides on the other side. And that's how they come up with this ratio. Okay, so if I see these two parallel sides, this is a little triangle and a big triangle, basically, think of it this way. Then I know that these two sides, PM and NM, get split up proportionally. So I'm going to write the proportion. X plus 1 over 12 has to equal X over 9. Now, as we've seen, there are a multitude of ways we could write this, but it still has to come out to be this. I'm going to execute the theorem as it said. Piece over piece equals piece over piece. If I cross multiply here, I get 9 times x plus 1 is equal to 12x, or 9x plus 9 is equal to 12x. Subtract the 9x, I get 9 is equal to 3x. And if I divide this solve, I get x is equal to 3. Okay? I could then substitute it in and find the measurements of the different sides too. But all they asked me to do in this question was find the value of x. All right, similarly, I recognize these two sides are parallel. That tells me that parallelism splits these two sides into a proportional relationship. So I know that a over a plus 4 has to equal 12 over 18. I could simplify. I'm just going to go ahead and distribute or multiply here. So I get 18a is equal to 12 times a plus 4, or 18a is equal to 12a plus 48. Subtract 12a, and that leaves me with 6a is 48. And if I divide this off, I get a is equal to 8. Again, they asked me to find the value of a. I found it. All right, that was side splitter. Now, a corollary to the side splitter is what I like to refer to as three parallel lines cut by two transversals. And what I've noticed here is it still has the same effect as side splitter. The relationship between AB and BC has to be the same as the relationship between WX and XY. And that's how they come up with this proportional relationship. It's basically like taking a triangle, and instead of it coming to a vertex up here, we just have another side. All right? So if I look at this picture, would this be an example of that corollary to the side splitter? Well, I know the relationship between 9 and 7.2 has to be the same as this side over 8. Well, the problem is I don't know this side. Could I find that side? Yes, let's call that side x. So I know that x over 8 has to equal 9 over 7.2. And I just double checked to make sure all my measurements they gave me in the picture were the same unit of measure. They're all yards, so I'm fine. If I cross multiply, I get 7.2x is equal to 72. And if I divide this solve, I get x is equal to 10 yards. Okay? What about finding c? Well, I'm going to call c y, side y. I again want to use this common relationship here, but now I'm also going to bring in this 6.4. I don't need the x or the 9 here. So my proportion would be y over 7.2 is equal to 6.4 over 8. And if I cross multiply here, I get 8y is equal to, let's use a calculator to help me here. Uh, 7.2 times 6.4 gives me 4608, and divide that by 8. So 46.08, or y would be equal to 5.76 yards. Notice I didn't round it. Why didn't I round it? Because they didn't tell me to. Okay, our second objective here is what's called the triangle angle bisector theorem. And the triangle angle bisector says, if you have an angle bisector, then what it does is it creates a proportional relationship between the two pieces of the base that gets split compared to each of the corresponding sides. So this one's a little bit tricky. You got to follow the pattern. If I have an angle bisector, then CD over DB has to equal CA over AB. All right, so let's take a look at this picture right here. All right, in this picture, we have an angle bisector. That's it right there. I know that 18 over 10 equals x over 12. Notice the pattern. So I'm going to start and just follow the theorem exactly. 18 over 10 equals x over 12. Once I create the proportion, it's pretty easy to solve. I just have 10x is equal to 18 times 12, which would be 216, or x is equal to 21.6. Done. Okay? Are there variations of the proportion that I could write? Yes. There are variations. Are they going to be equivalent? That's what you got to make sure of. So I'm following the theorem literally. Okay? Let's try one more here. I recognize this is an angle bisector. I notice that the angle bisector tells me it splits the side into a ratio, 9.6 over 16. And that ratio is comparable to its corresponding sides, y over 24. Notice 9.6 and y are both on the top, 16 and 24 are both on the bottom. If I cross multiply here, I get 16y is equal to 9.6 times 24, which would be 230.4. And if I divide to solve, I get 14.4. Again, there's no unit of measure, so I'm not worried about that. Okay? Hope this all makes sense. Let me know tomorrow in class if you have any questions about the triangle angle bisector, about 3 parallel lines cut by 2 transversals, or about the side splitter theorem.